Okay, the next problem that we're going to do comes from section 3.2, which is problem solving and using business applications for systems of equations. If you want to follow along with the problem, because I'm going to read it to you, it's on page 193 in your book. It's problem number 23. Alright, it says the manager of a candy store at a large multiplex cinema has a popular candy that sells for $1.60 per pound. So I'm going to go ahead and start by calling that popular candy X. And it sells for $1.60 per pound. The manager notices a different type of candy worth $2.10 per pound that is not selling well. So we'll say the not popular candy, or you could say unpopular to be a little bit more correct. And it sells for $2.10 per pound. How many pounds of each kind of candy should be used to create a 75-pound mixture selling for $1.90 per pound? And he's doing this to help clear the inventory of the more expensive type. So he's mixing it with the popular kind in hopes to be able to sell it and get rid of it a little bit quicker. So the first thing you need to get from that sentence is that he needs to create a 75-pound mixture. That means the popular candy plus the unpopular candy has to equal 75 pounds. Okay, this is your first equation in your system of equations. Right, the next part of the sentence says that the mixture has to sell for $1.90. Well, that's when you include the prices in your next sentence. So it's going to be 160 times X, because each of the popular pounds is $1.60, plus 210 times Y, and you want the mixture to equal $1.90, and we have 75 pounds of that mixture. You have to have a number here, which we are representing as X, here is Y, and then here is the total pound mixture. If not, you're not going to get the right answer. So this is our system of equations. Obviously, it's not an easy thing to set up, and it's definitely not an easy thing to solve either. You have plenty of methods that you can use to solve this. You can either use elimination, substitution, or even graphing if you really wanted to. The best method for a problem like this is substitution, because you have X and Y by itself in this first equation. So you're going to pick one variable in that first equation to solve for, and I'm just going to solve for Y, which means I'm going to move my X to the other side. So I get Y equals 75 minus X. And then what I'm going to do is where this Y is in the second equation, the one I haven't used yet, I'm going to plug in or substitute 75 minus X. So here's my next step. I'm going to get 160X plus 210, and then in parentheses I'm going to put 75 minus X. Now 190 times 75 we can go ahead and simplify, and that will give you 142.50. So I've got 160X plus 210 times 75 minus X equals 142.50. Now I'm going to distribute. 210 times 75 is 157.50. And then it'll be minus 210 times X. So I have this. Okay, now the idea is to combine your like terms. So I've got the X is already on the same side, so I'm just going to combine them. 160X minus 210X is going to give me negative 0.5X. And then what I'm going to do is I'm going to take this 157.50 and I'm going to subtract it from both sides, so that way I get my two numbers together. And 142.50 minus 157.50 is negative 15. So then I have this easy one-step equation to solve, and the only thing I have left to do is to divide by negative 0.5. And when you do that, you're going to get X equals 30, in this case 30 pounds. Now X represents our popular candy, so in order for the manager to get this mixture that he's seeking, I would have to have 30 pounds of the popular candy and 45 pounds of the unpopular candy, because I know it has to total 75. So my answer is 30 pounds of the popular, and Y is going to equal 45 pounds of the unpopular. Okay, and that is your answer. If you write this as an ordered pair, it would be 30, 45, because of the way that we picked X and Y. So this is an example of solving a system of equations.